Good morning, everybody. Thank you for fighting off your hangovers and coming to this early session. Hope that music got you energized as well. Kind of surprising music choice, right, the dubstep, but hopefully that gave you some motivation. I'm Simon Perryman. I'm a senior technical evangelist, and in this session, I'm going to be giving you an introduction to failover clustering, focusing on Windows Server 2012. Now, my current role as a technical evangelist, I'm kind of like a guy that goes to conferences, speaks to our customers, helps train and educate them. But prior to this role, I actually spent 4 years on the cluster engineering team as a program manager, designing and building a lot of the features that I'm going to be talking about today. Now, as part of this session, we're going to cover the basics of failover clustering, looking at our storage, our networking, best practices, but we are going to spend a lot of time focusing on Hyper-V virtualization and how we can optimize that for a cluster, as I'm sure a lot of you are here purely because of Hyper-V and trying to get that understanding of high availability for your virtual machines. Finally, we're going to wrap it up by talking about System Center 2012 integration with clustering, how we can take advantage of Operations Manager, Virtual Machine Manager, Orchestrator, and some of the other System Center 2012 components to really optimize the cluster and start to manage it at scale. Now, let's get the basics out of the way first. Now, expectation here is I'm going to spend the first 10 minutes or so going through the very, very basics of clustering. So if you've already deployed clusters before, kind of bear with me a little bit. This is just so we can kind of level set, get people on the same page, and really understand how a cluster is put together, how it works. Now, why is clustering important? Well, server downtime is inevitable, whether it's planned, whether it's unplanned. Now, one of the most common questions I get with Windows Server 2012 is, why do I still need a cluster if I can do live migration between any server in my data center, right? People used to think, hey, you only need clustering for live migration. But now that I can live migrate between two single servers, why do I still need a cluster? Well, the answer for that, clustering is used for unplanned downtime. When you do a live migration, both of your servers need to be online and actively participating in the live migration for it to happen. If you have a server that crashes, this is where clustering comes in. Once a server crashes, the other servers detect it's down and do a failover, bring those resources online. So clustering is still extremely relevant, extremely essential for all of your unplanned outages, unplanned downtime. So let's go through the basics of how does a cluster work? Well, very first step, you need redundancy everywhere. Storage, networks, servers, NICs, paths to your I/O, power supplies, internet connection, redundancy everywhere. Our goal with high availability, eliminate every single point of failure throughout the data center. Beyond that, you can even extend clustering across multiple data centers. So you can lose an entire data center, fail everything over to another data center that could be anywhere else around the world, fully supported with failover clustering. The next key requirement is that we have shared storage. This means that every node has access to our disk, to our data, and all of our application data is stored on this shared disk. Now, we'll spend a little more time talking about storage, but for shared storage, this could be iSCSI, serial attached SCSI, fiber channel over Ethernet, or even a file share using SMB 3.0. The key thing here is we need every node to be able to access the data. So if one server is unavailable, we can start an application somewhere else, still have access to all of our data. Next thing is, the cluster always writes this data to the shared disk. It's never writing data locally. Now think about that. If you have a VM on a standalone server, it's writing to direct attached storage, that server's unavailable, hey, that VM's not going to run. So again, shared storage is critical. We always write our data to a single location. Now the way that the cluster keeps track of everything that's within the cluster, all the different roles, the properties, public and private, and even the states of each resource, whether it's online, offline, failed, all of that's actually kept track of in a cluster database. So under HKLM/cluster, in the registry, we actually have a small cluster database, and this keeps track of the configuration of every single piece of the cluster. Now, anytime any node makes a change to that database, that gets replicated to every other node. So let's say a resource comes online on node 1. We update the database, we push out those changes to every other node in the cluster. This is important because this allows every node in the cluster to have a shared view of every other node in the cluster. So if one node goes down, all the other nodes know what that node was running. So always a consistent view. And you don't have to worry about any replication. Clustering handles all of that automatically. There's an internal engine called the Global Update Manager, or GUM. As soon as a change happens, boom, it gets replicated. Now, the next key thing is monitoring the health through what we call our heartbeat network. So we got to ask, what happens if a server crashes, the power suddenly fails? How does another server know that it's down? How does another node in the cluster know it's unavailable? Well, every node is constantly monitoring the health of every other node through what we call heartbeats. There's actually two types of heartbeats. There's a small heartbeat, which is just a ping test. We call that a looks alive test. And this is basically saying, does this server appear to be healthy? Does it appear to be responsive? Then we have a more intensive health check, which we call an is alive test. And with that, we will actually contact the cluster itself and confirm that the cluster service is running. So basically, every node is constantly checking the health of every other node. And if one of the nodes is unresponsive, we know there's a problem, and we can start to trigger a failover. So let's take a look at a quick graphical view of how this is laid out. Now, over here, we see we have a public network. This is what our clients are connected to, our applications, our customers, the public. They're going to be on an isolated network, just so in case they attack that network, it doesn't impact anything else in our data center. In the middle, you can see our heartbeat network. This is just our health check-in, constantly monitoring every node. At the bottom, you can see our shared storage. Both nodes can access a disk, and this is where our application data is running. Here I have a two-node cluster. One of the nodes is running my workloads. So this is just kind of a basic setup of a cluster. But let's actually figure out what happens when we have a failover. Now, with a failover, let's say node 1 fails. We're going to have a failover. So what actually happens? Well, node 2, remember, it's monitoring the health, right? It's saying, are you alive? Are you alive? Are you alive? But if this node has crashed, it's not going to be responding to that. So this is when we know that a server is down, and this is when we will start to trigger our failover policies, when our health checks start to fail. What we're going to do is, let's say node 1 crashes. Node 2 understands what node 1 was running because of that database, right? Every node knows what every other node was doing. Node 1 crashes. Node 2 understands what VMs it was running. What was the state of those VMs? What was the private properties of those VMs? So node 2 can now start up our services, our virtual machines, and bring them back to the exact same state that they were when they were on node 1 before node 1 crashed. So remember, this database, which is always consistent, ensures that any other node can run any workload at any time. It reads the data from the shared storage. Remember, all that application data is on a shared disk. We bring it up on node 2. Bring the workloads online. Reconnect our clients. But it's important to note, when you have a crash, there will be downtime, okay? The only way that we can have no downtime failover is for a planned failover, when we do a live migration and both servers are running. When we have a crash, there will be downtime. Now, a lot of people ask, how long does it take to bring a workload online? Well, some of it, depending on how much data you're loading, how much saved memory, sometimes it could take a few seconds. In some cases, it could take a few minutes. Now, in older versions of Windows Server clustering, 2008 R2, we actually had some workloads that might take 15 minutes to come back online, such as a print spooler. It would have to drain any existing print jobs. All of that's been updated in 2012. Everything should be coming online now in the order of seconds, if not minutes. So let's actually take a look at this failover in action now, using this same model. Now, in this case, we're going to go and crash node 1. It's offline. Our clients can no longer connect to our applications or our services. Now our health network comes in. The second node detects the first node is down. The second node also knows what the first node was running and the exact states of those. It brings those resources back online, reading the data from the shared disk, and then our clients are able to be reconnected. So that's the basics of a failover. Now let's start to talk about some of the other requirements we have. Cluster hardware, again, redundancy everywhere. Multiple networks, multiple storage, multiple NICs, redundancy everywhere again. Single points of failure, they're going to take down your solution. So failover clustered storage. Now, we support a lot of different types of shared storage here. We support storage area networks, SANs, iSCSI, serial attached SCSI, fiber channel over Ethernet, and in Windows Server 2012, we now support SMB 3.0 file shares. So what exactly does that mean? Well, what that means is you could go and create a file share on a file server, whack, my share. You could put your virtual machines in that share, and so long as all of your cluster nodes have read and write access to that share, you can actually use that as clustered storage. So our goal here was to really reduce the cost of requiring people to purchase SANs if they want to use clusters. You have a file share, a file server, you can now use that as your clustered storage. Now, multipath I/O we always want to recommend as well. Multipath I/O provides redundant paths to access our storage. So again, eliminate the single point of failure. Now with cluster networking, fully integrated with the TCP IP stack, we support IPv4, IPv6, 4-to-6 tunneling technologies. You could use static IP addresses for all of your resources for your cluster. You could use DHCP IP addresses. And we probably, in general, want to recommend using DHCP now. As we start to see customers move to these highly virtualized environments where they're quickly spinning up lots of VMs, you don't want to worry about IP address management anymore. So our goal here with DHCP, if we detect that there's a DHCP server in your environment, we will automatically assign free DHCP addresses to anything that you go and deploy on the cluster, trying to make things easier for you. Nodes can also live in different subnets. You could do live migration between different subnets. So you can actually move a running virtual machine from one data center to a different data center using live migration with no downtime. And all of that's free in box with Windows Server 2012. Now, a lot of people ask, though, how many NICs do I need for my servers? And this is one of the more challenging things because it really depends on what roles you're going to use as part of your cluster. Now, by default, you're always going to have at least 2 NICs, right? We always need 2 for redundancy. And so the 2 basic ones that you're always going to have is one for the public network. So this is our clients, our applications connecting to our VMs. And then one for the internal cluster communication. And so for internal cluster communication, that's our health checks, our heartbeats. These are our updates. When something changes in the database, we push that update out. All of that goes over that internal cluster network. So these are the 2 that you're required to have at most. Now, when we start to go beyond that, we really want to try to isolate our networks by different roles. What is this cluster network going to be used for? This is how we really try to isolate, because you don't want to have multiple networks, multiple uses for the same network path. Now, the primary reason for this is you don't want to block any heartbeats from going through. You don't want to block any health checks. Now, remember, these health checks are just pings, right? We ping one node to the second node. Now, what happened if that same network was entirely flooded with, let's say, live migration traffic? That network's fully saturated. Nothing else goes through. Well, if we're trying to send a health check through that network, the health check might not go through. We might not get a response, and this can trigger a false failover. One node could think another node is unavailable because that network's flooded. So we really always want to try to isolate these networks by usage. Make sure that we never block these health checks. Make sure that the nodes can always communicate with each other. Now, when we look at Hyper-V virtualization, we recommend adding 2 additional networks. The first network is for our live migration traffic. Again, live migration means that we're moving a virtual machine between different hosts with no downtime. We're going to spend a little time later explaining the details of how we do that, but we're essentially pushing through all of the in-state memory from one node over to another node. And so when we do this, it completely floods the network. So get a dedicated network for your live migration traffic. The second Hyper-V network is for your Hyper-V management. So what does this mean? Well, this isn't so much, hey, I need to go and log on to a server. But with management, it's more around deployment. So if you think, hey, I need to go and deploy a new image to my node, hey, if you're copying a 10 gigabyte file, that's going to go and flood the network as well. So we recommend having this isolated network just for your Hyper-V configuration, Hyper-V management, Hyper-V deployment, so that it's dedicated just for that use, just for copying things over, bringing things online, without impacting anything else in your cluster. Now, depending on what type of storage you're using, you may need to add a fifth network as well. Now, if you're using iSCSI, if you're using Fiber Channel over Ethernet, if you're using SMB 3.0, all of these go and communicate through Ethernet, through your network port. So you're going to want to have a dedicated network for your storage I/O. Again, we don't want to go and block traffic, right? We don't want to send our heartbeats through our storage network, have problems there. We don't want to impact our I/O from our node to our storage by having live migration traffic through that network. So again, isolate the networks by role. The sixth network, which you may need here, is if you're doing frequent backups. Data Protection Manager recommends using this network. Now, in some cases, we've seen a lot of customers be successful by combining their backup network with their deployment network or their Hyper-V management network. You know, most of the time, you're not always deploying things. You're not always doing a backup. So as long as you can schedule these well, you can combine these two networks and have your Hyper-V management network and your backup network going through the same NIC. Now, cluster scale, this has been one of the biggest improvements that we've made in this release. And right now, we're leading the industry as far as the size of the clusters that we can make. In our old release, it was 16 nodes, 1,000 VMs. We're now 64 nodes, 8,000 VMs in a cluster. Huge scale. Now, 8,000 VMs, that covers most of our customers that we speak to, you know, as far as, hey, can you run your entire environment in one cluster? But now, don't forget, even if you have more than 8,000 VMs, we can now live migrate between different clusters. So you can have an 8,000 VM cluster here, another 8,000 VM cluster, another 8,000 VM cluster, and freely move all of the resources between all of these different clusters. So even though we're limited at 8,000, with new live migration features, essentially, you can make clusters on clusters and clusters and scale out indefinitely. Now, on a single node, you're limited to 1,024 VMs, so over 1,000 VMs per node. But we rarely see people get to that. Now, one other SKU that I want to briefly talk about is Hyper-V Server 2012. Now, this is an entirely free version of Hyper-V that comes with clustering. So what you could do, you just go to downloads.microsoft.com, get Hyper-V Server. And so our goal with the Hyper-V Server was to give people an opportunity to play around with Hyper-V, play around with clustering entirely for free without having to worry about any licensing. So Hyper-V Server supports 64-node clusters, 8,000 VMs, cluster shared volumes, live migration. So a lot of people ask, you know, why would Microsoft give this away for free? Well, it's important to remember that this version only supports Hyper-V and failover clustering. It doesn't come with file server, DNS, Active Directory, DHCP. So you're still going to kind of need that core infrastructure services in your environment, but just for your Hyper-V hosts, it's a great solution. Now let's look at this a little more. One other consideration with the Hyper-V server is since we're giving it away for free, that's just the host operating system. You're still responsible for licensing your actual virtual machine guest OSs. Okay, we give away the host for free. You still need to license the virtual machines. But of course, you could run Linux inside those VMs. So you could have an entirely free solution. Hyper-V server on the host, Linux inside the VMs. Free solution throughout the stack. Now, other big difference here is that Hyper-V server only has command line interface. It does not come with a graphical user interface. But it can be managed remotely. So if you have Hyper-V server, yet you still have a full version of Windows Server somewhere, you can still manage it remotely through Hyper-V Manager, Failover Cluster Manager, System Center Virtual Machine Manager, or you can even download what we call RSAT, Remote Server Administration Tools, which is basically allows you to manage your server infrastructure from your Windows client laptop. So you can have Windows 8 client on your laptop, go add remote server administration tools, and still get that full graphical user interface to manage your Hyper-V servers. Now, there's also a lot of third-party companies out there like Five9, which actually provide utilities that you can install on Hyper-V server and give you a graphical management interface. So the key point here is, even though there's no GUI built in, Don't be afraid of the command line, or don't be afraid of adding a utility on top of it. Still get that full management experience. Now, with Windows Server 2012, we also reduced the number of different versions there are. For your data center people, our server guys, you need to just think about 2 versions now. Windows Server Standard Edition, Windows Server Data Center Edition. Now, why would you choose one or the other? Well, it really comes down to virtualization rights. Data Center Edition comes with an unlimited number of licenses for your guest operating systems, for your VMs. So if you're in a highly virtualized environment, you want to deploy lots and lots of VMs, never have to worry about licensing, go with Data Center Edition. If you're not highly virtualized, Standard Edition might make more economic sense for you. With Standard Edition, it gets 2 guest operating system licenses for every 1 physical host operating system license. One other thing I want to mention here as well. With Windows Server 2012, failover clustering also comes in Standard Edition. So failover clustering now available in Standard Edition as well. That's new with 2012. Now, as we look at the terminology, clustering has evolved a lot. Now, today we're called Windows Server Failover Clustering, which we've been called for the past 2 releases. Back in the day, it used to be called Wolfpack. Now, show of hands, did anybody do Wolfpack clustering a long time ago? A few of you. You guys are brave hanging in there. Things have been a lot better recently. Now, kind of the key thing here, why I bring this up, is if you're looking for documentation, you're looking for guides, help, you want to make sure that you find references to failover clustering. If you find references to a Microsoft cluster service, older versions, that documentation is not going to be relevant. The entire product's been rewritten since 2008. And so if you find references to MCSE, Microsoft Cluster Service, ignore it. It's not going to be relevant anymore. Make sure that you find documentation for Windows Server failover clustering. Now let's move over into configuration. What are the basics of failover cluster configuration? Well, we wanted to really simplify this. Failover clustering configuration was one of the toughest challenges that we had in the past. Now, if people did Wolfpack, if people did clustering in 2003, it is hard, okay? To actually build a cluster, you need to read about a 50-page white paper back in the day. If you wanted to change a part of your cluster, let's say you needed to go replace a network card a year later, it needed to match this exact list, the hardware compatibility list, HCL. If it didn't, your cluster was no longer supported. And so this just caused a lot of pain, a lot of customer dissatisfaction, and a lot of calls to product support. So we said, hey, does the hardware really need to be identical? Probably not. We said, hey, does every single node need to be part of an exact list that Microsoft needs to maintain? Probably not. There's so many hardware vendors. Having Microsoft maintain a list of every possible cluster configuration, it just doesn't make sense. There's literally an orders of magnitude of different options here. You know, if you think every vendor in the world, every type of NIC, every type of firmware edition, it was pretty impossible to maintain this list. So we scrapped all of that in 2008. We said, you know what? If clustering passes this built-in set of tests, you have a supported cluster. And so that's the basics of it now. To have a supported cluster, you have to pass our tests, our validation tests, and every component must be logoed for Windows Server 2012. That's it. It could be dissimilar hardware. So long as everything passes, it's fully supported. Now, I do want to make a comment about the dissimilar hardware. It's definitely recommended to have consistent hardware across the cluster. The reason why is so that the applications always behave the same, no matter what node they're running on. You know, you don't have to worry about different firmware, different drivers. So definitely nice to have consistent hardware, not required. Now, there is one time where you will always want to make sure that you have consistent hardware. That's if you're going to want to use a live migration. Now, the reason why, when we do live migration, we need our processors to be in the same family. So they must all be Intel, or they must all be AMD for a live migration to work. We cannot live migrate from an Intel node to an AMD node, okay? So make sure you have the same processor family. Now, they can be at different versions of processors. Now, there's actually an option within clustering, within Hyper-V, called processor compatibility. And so let's say you have a version 5.0 Intel processor on one node, a version 10 on another. Well, what we do, we'll still support live migration, but we will bring the higher level to a reduced version. So essentially, both of them would be running at version 5. So fully supported, it just means that it may not be as fast. Now, let's actually switch over to our demo now and talk a little more about cluster validation. Now, cluster validation, end-to-end set of tests, this is what's going to be required for the cluster to pass, for it to be fully supported. Now, what I have over here is a Windows Server 2012 failover cluster. It's going to have 3 nodes here, and I've already configured my storage. So currently, I'm going to use iSCSI, which is Microsoft's built-in shared storage, Microsoft's iSCSI initiator. And currently, I'm connected to my iSCSI target. So right now, I have my 3 nodes. All 3 nodes are connected to my iSCSI target. So first thing I'm going to do here is go and say validate my configuration. It asks me for the names of my nodes that I'm going to enter. So node 1, node 2, node 3. It's going to verify that the failover clustering role is installed on every node. That's what this test does here. It's confirmed it's installed. I click Next, and then it asks me what tests I want to run. Now, to have a fully supported cluster, you need to run all of the tests, and none of them can fail. So you're going to see shortly that there's going to be 3 different results for each of the tests. Pass, which means everything is good. Fail, which means it's not supported. And a warning. Now, warning means that it will work, but a best practice is not being followed. Now, the nice thing about this cluster validation test is this is a troubleshooting tool as well. Let's say you're having trouble with your cluster a couple of weeks after it's deployed. You could go run validation, and it will go and retest the entire cluster. You have the option of doing it with no downtime, so it won't bring down any applications. Now, additionally, if you go and run cluster validation once the cluster has been deployed, it will actually run a whole new set of tests as well, called our configuration tests. So if you run it before the cluster is deployed, you don't get these tests. You run it once the cluster is running, you get these extra configuration tests. And this is going through every single private property of every clustered role and checking that best practices are being followed. And it's extremely granular. For example, it will look at what is your disk online option. Are you running check disk when your disk comes online? Which version of check disk are you running? Are you running the fastest version of check disk? And it will recommend, hey, you're doing slow check disk, you should do fast check disk, because this means after a failover, the application comes online quicker. So great way to troubleshoot and really try to optimize the cluster and reduce product support calls when something's not working. Now, cluster validation tests, it can take a while, but it's been significantly improved in Windows Server 2012. Now, one of the things that takes a while with the cluster validation test is, in the past, we used to test that every single disk could come online and be seen by every node in a cluster. But we had some customers. We had a customer that ran a big social network, and it would take them actually days to do cluster validation. They had a 16-node cluster with over 500 disks. And so we were testing 500 disk onlines for every single node in the cluster. Highly inefficient. So we fixed that with this version. It's over 900% faster, these storage tests. So we made significant improvements in everything that we test here. So you'll find all of these tests run much quicker. But for the sake of time, I'm not going to go and run every single test here. I'm just going to go and run this new set of tests for Windows Server 2012, which are our Hyper-V configuration tests. So these are tests purely designed if you have the Hyper-V role installed. We figure, hey, you have Hyper-V, you're probably going to have a Hyper-V cluster. Let's go and make sure that this cluster is optimized for Hyper-V. So I'm going to click Next, confirm these settings pretty fast, and then we have the option to go and actually view the report. So let's quickly walk through these Hyper-V tests, because even if you've done clustering before, these will be new for you in 2012. Now, with the Hyper-V test, we're essentially going to ensure that this is designed to run virtual machines as best as possible. So first of all, we're just going to go and collect information about these actual hosts. So we check that the Hyper-V role is installed, and then we have the option to look at VMQ and SRIOV. VMQ and SRIOV, these are network optimizations which can be used for Hyper-V. So you can do offloading to a NIC, do additional processing on the NIC, things like that. In this case, I actually don't have NICs that support SRIOV, and VMQ is disabled, so this shows up as false. Next set of tests is make sure that you can have virtual fiber channel SANs if you want here. Now, I haven't configured this. Nothing shows up. We check the Hyper-V memory resource pool. So this makes sure that if they're sharing any type of memory, any resource pools, it will highlight this ahead of time. Haven't configured that. We're going to check for virtual switches. Make sure that we see a consistent virtual network across all of my nodes. Now, why is this important? Well, let's say I have a VM running on node 1, and the VM's configuration says it's using network 1. Well, if I move that VM over to a different node, and on that second node it's called network 2, the VM's not going to work because it's configuration network 1, network 2. So what we're doing in this test is we're ensuring that we have a consistent network name for our virtual networks across all the different nodes in our cluster. In this case, I do. All of my networks have the same name. We're going to check the Hyper-V role is installed. And these other tests here, they're just additional tests for the resource pools for storage. Finally, we're going to check that we have matching processor families. So in this case, I'm using Intel, and I have identical processors in all of mine. So great, we have a great Hyper-V host here. Now, I actually ran a full validation test a little earlier this morning to make sure that everything would be supported when I go and deploy this cluster. Now, in this case, you can see that I actually have some warnings. So let's just take a quick look at these here. So I can see with this set of warnings, it's telling me I'm not following a best practice. My nodes can only speak to each other over a single network interface, a single NIC. So this is telling me I have a single point of failure. The cluster will work, but I'm not following a best practice. So just a nice example of how you can get up and running, reduce future downtime, and make sure you're following best practices before your cluster's even up and running. So let's switch back to our cluster, and let's actually go ahead and create the cluster now. Now what this does, it will actually go and launch our Create a Cluster wizard. But it will pre-populate the nodes that I've tested. So instead of having to enter my 3 nodes once again, it already knows what nodes I'm going to use in my cluster. So I'm going to click Next. Now it gets to specify a name. Call this Simon P. MMS 13. Click Next. It's going to validate that that name is free in Active Directory. I have the option to automatically add all eligible storage to the cluster. Click Next, and our cluster is going to be created. Now, this will take about 30 seconds, but in the meantime, let's switch back to the presentation and keep going through. So, next concept that I want to talk about while this cluster is being created is the concept of quorum. Quorum is our membership model. Now, the importance of quorum is to ensure that there's always a consistent view of the cluster, and there's only one version of any application running at one time. So let me clarify that a little more. We had this problem in the past of what's called a split brain. Now, with a split brain, this is essentially where you have a network partition in your cluster. I have node 1, I have node 2, but these 2 nodes can't talk to each other. We have a network partition. Maybe they're in different data centers. So the question is, should node 1 be running my virtual machine, or should node 2 be running my virtual machine? They don't know. They're not able to talk to each other and see the state of each other. Now, this would cause a problem in the past because both nodes would try to start the same virtual machine. They'd both be writing to the same disk at the same time, and simultaneous, uncoordinated disk writes can cause corruption. So we need to avoid that. Our goal here with split brain is to always ensure that there's a single owner of an application at any point in time. So we do this with our cluster model. Basically, we have an algorithm that will always ensure that only one group of nodes or one node is running an application, and the other groups of nodes will not run that application. So they're never running simultaneously. So let's go into this a little more and figure out how exactly do we do this. Well, we do this using a concept of votes. Pretty basic. A node can have 1 vote. A disk can have 1 vote. Or in some cases, a file share can have a vote. So let's say I have a 3-node cluster. We can give each of those 3 nodes a vote. If I have a partition, I have 1 vote on one side, 2 votes on another side, the side with 2 votes has majority, has quorum. That's the side that's going to go and run our applications. Now, majority is always greater than 50%. Not 50%, greater than 50%. We must always ensure that one side has more than 50%. And so to do this, we always need an odd number of votes. 3 votes, 5 votes, 7 votes, 65 votes if you want. But it must always be an odd number of votes so that we never get exactly 50-50 partitions. So let's actually look at the 4 quorum types that we have here. So the first one, the most common one, you're going to see if you have an odd number of nodes, 3 nodes, 5 nodes, etc. And with this, every node has 1 vote. So no matter where we have a partition, as long as there's only 1 partition, there will be a majority of voters on one side, a minority of voters on another side. The side with majority wins, it stays online. The side that does not have majority will patiently wait. It will try to contact those other nodes and try to rejoin the cluster. But this way, we always ensure that the majority, the side that has quorum, keeps the resources running. The side that doesn't waits patiently. Now, the next model we have is node and disk majority. You're going to use this quorum model if you have an even number of nodes, 2 nodes, 4 nodes, etc. In this case, all of those nodes get a vote. So let's say my 2 nodes get a vote. And then I have a disk that has a 3rd vote. Now, what happens here is one of those nodes will own the disk. The other node will not own the disk. So the node that owns the disk, that has majority, that has 2 votes. The side that doesn't own a disk, got to be careful with my fingers here, that side will not have majority, that side will stay offline. So think of this disk as an extra vote. One of those nodes will have an open file lock on the disk. That's the side that has majority. Next type that we have is node and file share. So in this case, it's the same concept of node and disk. The difference is we give a file share a vote. So why would you want to use this? Well, this could be useful if you don't have extra disks, don't have to want to worry about SAN management, storage management. Basically, so long as these nodes have access to this file share, we will go and use that file share as an extra vote. And so what happens in this file share? Well, there's actually 2 files in there. There's one file that we use as a read and write test to make sure that our nodes can write to it. And then there's a second file that we use to have a lock on it. And so what will happen is one node will go and have an open file handle on that file share. It will lock this file. If any other node tries to write to it, it will see, hey, someone's already using this file share, someone's given this vote, and that vote goes to that node. So it's the same concept as a disk, always ensuring a single consistent owner to ensure a single vote. The 4th one is what we call disk only. In this case, we have 1 disk, 1 vote. But we say this is not recommended. Anyone know why this is not recommended? Single point of failure. You lose that disk, you lose your cluster. You only have 1 vote. So why would you still want to go and use this? Well, really, the only reason why we see people use this is for what we kind of call a last man standing vote. Let's say I have an 8-node cluster. I want it to run so long as 1 node is online. I can lose 7 other nodes. So long as my 1 node is online, has access to the disk, the cluster will stay up. But you've got to ask yourself, if I'm usually running all of my resources across 8 nodes, 7 of them have crashed, is that last node really going to be able to keep the performance, the disk I/O, everything else running from those other 7? Probably not. So you still want to be cautious about capacity planning. Now, one of the other enhancements that we've added in Windows Server 2012 as an optional configuration is what we call dynamic quorum. Now, dynamic quorum essentially has this same concept as last man standing. But rather than just have a single vote, if a node crashes, becomes offline, we will actually just remove it from the voting pool. So let's say I had a 5-node cluster with 5 votes. 2 of my nodes crash. They're not coming back online. If I have dynamic quorum configured, then I'll only have 3 votes remaining in the cluster, and all 3 will be online. So gradually, as nodes come online, we can change the number of votes assigned to the cluster. Now, I would say this is more of an advanced configuration. We generally see this used with multi-site clusters where we have nodes, where we have 2 sites, different number of nodes at each site. But it's still an option that you can consider. There's a good TechNet article about that, best practices to use dynamic quorum. But if you're new to clustering, just want to get the basics, I would suggest not worrying too much about this setting here. Now, cluster shared volumes, version 2.0. This is our distributed access system, which is optimized for Hyper-V. Now, what we mean by this is we can allow our nodes to simultaneously access a disk at the same time without causing that corruption. Remember a little earlier we said we have to be cautious if we have one node hosting a VM, another node hosting a VM, having them write to the disk at the same time? Well, with cluster shared volumes, we basically control which node writes at which time. So if we have 2 VMs writing to the same disk, we will actually coordinate the writes so that they're not writing to the same block at the same time to avoid any type of corruption. If you're a VMware person, this would be equivalent to VMFS, VMware File System. Now, what this does is it allows us to basically have multiple VMs running at the same time, writing to the same disk. And this is just to simplify storage management. In our older versions of clustering, we had to have a single virtual machine for each disk. So if you had 8,000 VMs in your cluster, you would have to have 8,000 disks. Not true anymore. We now can optimize it and have multiple VMs running on a disk. And we've been able to support this since 2008 R2. But in Windows Server 2012, we've enhanced this further. We now support the new Hyper-V over SMB 3.0. So you can use that on cluster shared volumes. We also support a new type of file server called scale-out file server. This is actually also called continually available file server. There's different configuration options. But what this does is this allows us to actually have our file share on multiple nodes that are running, up to 4 nodes at once. And so what this means is you can have whack my share across 4 different nodes. And when clients come in and try to connect to that file share, they actually get split across those different nodes to reduce the amount of disk I/O. But more importantly, the scale-out file server allows us to have a node crash and have 0 downtime for anyone accessing our file server. So let's say my client's connected to node 1. Node 1 crashes. They automatically get reconnected to node 2, no downtime failover. Now, if they're in the middle of a file copy operation, the file copy will pause. Depending on what file copy program you're using, if it's set to automatically retry, such as robocopy or xcopy, it will do that automatic retry, and it will continue file copying on node 2. So this basically allows you to have crashes, allows you to do failover, allows you to do maintenance on your file server with no downtime to clients actually accessing that file server. A question? The question is, does each server of those 4 servers have all the data? All of the data is going to be on shared storage again. So it's always on the back end on a single disk. So it's basically the path goes to that disk. So it's not on every node, but it's on that shared disk, and we redirect to that single disk. Is there a client OS requirement? You have to at least have Windows 7. If you're using SMB 3.0, you need to have a client that supports SMB 3.0, which I'm not sure if Windows 7 does or whether that's Windows 8 only for SMB 3.0. So if you're doing SMB 3.0, you need to have that supported. For regular file servers, Windows 7 and above. All right, well, let's jump back to the demo here. Now, we've just finished creating the cluster. We get a nice little report here as well. So if we want to have information about how the cluster was created, what names we use. And one thing that you're going to find with clustering that we've had around for a while is anytime we go and create a report, anytime we perform an action, deploy a cluster, create a role on the cluster, we'll actually have the ability to store those reports automatically in this folder. Sorry, I'm having a little bit of network connectivity issues. Just got disconnected a minute ago here. So you know what? Let me get that back up and running. I apologize for that. Don't hate on me because I have a bad network in the room. We'll come back to the demo in 1 second once I get reconnected. Next thing I'm going to talk about here is cluster management. So what can you deploy on a cluster? Well, pretty much anything. That's one of the great things about clustering. We have inbox support, and then we also have an extensible platform to allow you to basically run anything that you want on a cluster. Now, the inbox roles that we see most of our customers use, about 90% of our customers, they're using Hyper-V, SQL, Exchange, and File Server. And so you're going to see a nice integration with all of these different roles throughout the cluster, such as being able to launch Hyper-V Manager straight from Failover Cluster Manager. We then have other inbox roles, so DHCP server, MSMQ, etc. So a lot of these different applications you can run on your cluster. Now, next category that we have are generic containers. Now, with a generic container, this basically is a wizard that gives you the ability to run any type of script, any type of application, or any type of service and make it highly available. So you go through a wizard and it says, what's the name of your application? myapp.exe. Clustering will actually go and monitor that, make sure that the application restarts if it crashes, fail it over if it needs to, throughout the entire cluster. Now beyond that, it's also extensible as well. If you want to write your own resource DLL, you have developers, you can actually create your own, basically your own library that will go and run any type of application you want on top of a cluster. So how do you go and do this? Well, basically what this is, it's a mapping of actions for your application to actions that the cluster cares about. So for example, the cluster wants to know what is an online of a resource. That could be something like netstart myapp.exe. You go and map those together, so when we say bring this resource online on the cluster, under the covers, it will actually go and run that command, netstart.exe, bring your own custom application online. So you have similar mappings for bringing the cluster offline, checking the health of that application, and then just a whole variety of other different types of cluster actions that you can go and map to your own application. So you could essentially make your own apps, your in-house applications, first-class citizens on top of the cluster. Now, a cluster is maintained with what we call a cluster group. And a cluster group is our logical unit of failover. So what I mean by that is, when you go and move your virtual machine from one node to another, you move your file server from one node to another, we actually move this entire group of resources with it. And so what comes in a clustered group? First of all, you actually get the network name. This is the friendly name for your virtual machine, your application, the way that we go and connect to it. Next, you have the actual application itself. So this is what we're making highly available, our file server, DHCP server, etc. We then have our disk resource. So which disk, which storage on our shared storage is associated for that particular application. And then we have our IP address. So what's the underlying mapping for this particular workload? And so when we do a failover, we grab all of this information, our disks, our IP addresses, our network names, and bring these from our first server over to our second server. That's our group of failover. This way, everything moves together, everything is bound to a single host together. Now, virtual machines are slightly different. With virtual machines, VM groups, we have a configuration file which includes all the information about how that virtual machine is set up. So what's the name of the VM, memory, disk, virtual networks, things like that. And then we have the actual VHD or the shared storage that it's going to be using. Now, one of the new features that we added in Windows Server 2012 is what we call group priority. This gives us the ability to go and order all of our different virtual machines or any other resource throughout the cluster. So we can say this VM is more important than this other VM. So when would you want to use this? Well, this is important when you start up all of your virtual machines or other resources, right? In many cases, you want to start up some before the others. So for example, if your entire infrastructure is virtualized, your domain controllers, DHCP servers, DNS, you want to bring all of those online first. Those would be high priority. Then your medium priority might be your line of business applications. things that are important to the business but won't actually be up and running until AD is there. And then you have your low priority things, things that aren't critical to bring online, nice to have, eventually those will come up later. And then there's the fourth option, no auto start. I'm going to talk a little more about this later, but this basically says don't go and run these VMs until I manually start them. Now, the reason why this was really important was with virtualization, when you actually go and start up a VM, it uses up a lot more resources than when it's running in production. In general, not always, but think about when you actually start up a VM, what happens? Well, the VM has to start the guest operating system, the integration components, it loads the drivers, it loads startup scripts, boots the OS. And so there's actually a lot of processing that happens when you go and start a VM. Then after a while, it kind of stabilizes, and it's not using as much resources, as much memory. So we had this challenge in the past where the entire cluster would crash. I'd try to start up 100 VMs at the same time on that node, and those 100 VMs in normal production would run fine, but when they were starting up, they would use up twice as many resources that that particular host could handle. This is a startup storm. Everything would start up at once, it would overwhelm that host, and cause that host to crash. Now, those VMs would then fail over to the next host that was already having a startup storm as well. You add more VMs that are trying to start up, cause that to crash, and you'd almost have a domino effect where you would gradually bring down the entire cluster while you were trying to bring it up because of these startup storms. So using prioritization, this helps us eliminate that. It brings all of our high priority ones online first. So we just got a smaller startup storm. Then our medium, then our low. So it's essentially staggering the startup of all of our VMs across all of our hosts to avoid these startup storms. Now, with no auto start, this is essentially our ability to disable low priority groups. So, maybe you have some internal file servers for a particular team, human resources, their database, things like that, things that just aren't business critical. You have the ability to say, don't start up at all. We're going to wait for our cluster to come online, everything to be healthy, everything to be stable, get past our startup storm, and then we could go and manually start up these low priority VMs. So yes, you could do it manually, you could do a script, you could have some type of delay start on the VM. Now, next option that we have is given the ability to group our resources, our VMs or other applications on a particular set of hosts. So why would you want to do this? Well, maybe you have 2 extremely powerful hosts that are brand new, and then you have 8 older hosts that were part of your old cluster. Well, you might want to have your most important business-critical applications run on those 2 most powerful hosts. The less important ones run on the other hosts. So using this preferred owners, you can actually specify that a particular role or a particular VM will automatically be bound to that one host or that group of hosts. If that preferred owner, that first choice owner, is unavailable, then it will go and start up on a possible host. So think of preferred owners as first choice, possible owners as second choice. So if there's no first choice available, they'll go to a second choice. So this essentially gives you the ability to prioritize your hosts as well. And this is set on an individual role level. So on VM1, you can go and specify all of these options. On VM2, you can go specify these options, completely independent how they interact with each other. Now, if neither a preferred owner or a possible owner is available, the resource will actually not come online. So we say, hey, if your first place aren't available, your second place aren't available, we're going to keep it offline. We're not going to go and automatically start it. Now, another new feature that we added in Windows Server 2012 was what we call node maintenance mode. Now, node maintenance mode helps us when we need to go and service a particular node. Now, in the past, let's say I needed to take a node offline and I had 10 virtual machines on it. I'd click on the first, I'd live migrate, wait for it to finish, do it again on the second, on the third, and it would be kind of a tedious process to gradually drain this host. Well, what we have with node maintenance mode, we have the option to simply say, drain all of the roles. What it will do is it will pause the node, and that means nothing else can move onto this node. And then gradually, all of those VMs will live migrate themselves off using prioritization. So all the high priority VMs go off first, then medium, then low. And so it's a single-click operation, Go get a coffee, come back later, the node will be evacuated, nothing else will move back on it, then you can go and do your regular maintenance. Take it offline, go repair a disk, whatever you need to do there. Another enhancement that we made in Windows Server 2012 was cluster-aware updating. And this is basically, again, to solve one of the most repetitive manual tasks that people complain about in our old version, cluster patching. Now, with cluster patching, very, very tedious, right? You'd have to go to the first node in a cluster, evacuate it, or pause it, evacuate it, figure out what patches there were, apply the patch, reboot, see if there's any other patches that are needed, apply those, reboot, make sure it joins the cluster, take it out of maintenance mode, move everything back, and then go and repeat that for every other node in the cluster. Now, that was bad in 2008 R2 when we had 16 nodes. But now that we scaled up to 64 nodes, we said, hey, we need to build an automated solution here. And so what we do here with cluster-aware updating, we basically go through that process that I just described automatically, patching all of the nodes in your cluster. Now, cluster-aware updating is a separate feature that you will go and install from Server Manager. Once you have that up and running, you could go and assign a series of patches, and we call that a baseline. So basically, you say, hey, I want these 10 patches to be applied to my cluster. We call that our baseline. We'll then go and scan the different nodes in the cluster, figure out which nodes need which patches. And then we'll go serially, one node at a time, put a node into maintenance mode. That automatically drains everything off it, patch it, reboot, make sure that the node gets rebooted, it comes back online, that the patch installation code returns successful, and that that node can rejoin the cluster. Once all of those requirements are met, we say the patch has been successfully installed, we take it out of maintenance mode, and then we go and do this on the next on the next node, and we cycle through this. And so we have some customers now that have these 64-node clusters, hundreds of VMs that are doing live migration, and they're almost in a continual state of patching. And that's okay in this fluid, dynamic environment. They're literally patching almost 24 hours a day, 7 days a week, because they have such big clusters. But for them, it's no longer this manual process. It's no longer a burden on their IT staff. It's fully automated. They select the baseline, they click go, come back the next day, cluster's been patched, no downtime for any of my VMs, any of my applications. Now, let's talk a little more about some of the VM best practices that we have here. Now, up to now, we've talked about host clustering. This is what you're most familiar with, where we have our physical servers that are connected to actually go and form our cluster. Now, the benefits of this, we can prevent against any downtime, hardware failure, a VM crashes, we can detect that. We could even detect the guest operating system of a VM. So this basically allows us to move our virtual machines or our other applications between different hosts with no downtime. The next type of clustering that people are less familiar with is what we call guest clustering. And with guest clustering, we're actually clustering our virtual machines. So I have my virtual machine that's running Windows Server 2012, 2008 R2, another virtual machine that's running Windows Server 2012, and we'll actually create a cluster between those two virtual machines. So what's the benefit of this? Well, if we need to patch our guest operating system within our VMs, we can move our applications between those two VMs, patch our guest operating system. We have application recovery. So if I have a SQL server running inside my VM, that SQL server crashes, the other node can detect it, we can restart it, we can fail over the SQL server. So this is basically giving us high availability inside our virtualized layer. So we can have high availability on our physical layer, high availability inside our virtual layer. Now, storage is a different consideration when you're using guest clustering. We do have some limitations on what type of storage you have. In our older version, 2008 R2, you had to use an Ethernet-based protocol. So iSCSI, Fiber Channel over Ethernet. With Windows Server 2012, we've now added a virtualized HBA for Fiber Channel. So this means that you can use Fiber Channel storage and still have access from your guest operating system. So we can actually take advantage of our fast Fiber Channel storage with Windows Server 2012. Now, one more question that I often get asked here with the guest clustering is, can I combine host clustering and guest clustering at the same time? Absolutely, so long as validation pass. You essentially have a cluster made out of your physical servers, so you have high availability for your VMs. You have another cluster made out of your VMs, your guest operating system, so you have high availability for those applications within the VM. So yes, you can have a cluster on top of a cluster, so long as both clusters pass their own independent cluster validation tests. Now, we also want to be able to monitor the health of our actual VMs as well. Not just the operating systems, not just the host, but actually go peek inside our operating systems. Check that our VMs are healthy. I'm going to hold off questions as I'm running out of time. So what we do with our VM health monitoring is we'll actually go and monitor the health of the VM, check that it's running by checking the integration services, checking the guest OS. So if our VM actually has a blue screen, our VM has a user mode hang, we'll actually say, hey, this VM's unhealthy, our applications aren't running within it, let's start that VM. So we're actually monitoring the guest OS as well, making sure that that stays online, making sure that that stays healthy. Now, Windows Server 2012, we've gone even further. So now we're not just monitoring the hosts, the hardware, the VMs, the cluster, we're actually peeking inside the VM, and we can monitor the services that are running within a VM. So what we do with VM service monitoring, from the host, you can actually go and specify, hey, VM number 1, what services is it running? It will list anything that runs in Service Control Manager, and it will go and monitor the health of that particular service. So if you have a service within a VM that freezes, that crashes, we can automatically restart that service from our host. We can restart that VM. We can move that VM to a different host, try restarting it there. So our goal here, just additional redundancy, additional resiliency, keep things running better, keep things running online. So with this, again, we peek inside, restart those services, restart those applications. Now let's talk a little bit about some of our migration options here. What's the difference between quick migration, live migration, and how exactly do they work? Well, quick migration we've had since Windows Server 2008. With this, we are able to move a virtual machine from one host to another host, but there is downtime. So some people ask, why would I still care about quick migration, right, if I have live migration? Well, quick migration is actually faster than live migration. So let's say there's a virus that's infecting the data center. We need to quickly evacuate our hosts and patch them. You might actually want to quick migrate things off just to move everything off as quick as possible. Again, there will be downtime. So what actually happens with our quick migration? One key concept with virtualization is you need to keep in mind that we have what we call in-state memory running on a host. So we have our data that's on our disk, our shared storage. We have our host. We have our virtual machine. And any memory that's part of that virtual machine will actually be running on that host. We call this our in-state memory. And so what we want to do with a quick migration is move that in-state memory as well. So we're not actually going to shut down the virtual machine, take everything offline, restart it, restart our operations, restart our services. We don't have to do that with a quick migration. What we're basically doing with a quick migration is saving our in-state memory to a disk and then reloading that in-state memory back on another node. So this means after the quick migration, we're not restarting our VM cold. We're restarting our VM and applying that in-state memory so that our services and applications can start running much quicker. So what we do here, we say, perform a quick migration. We're going to save the state of the virtual machine, so save that in-state memory to our disk. We're going to go and bring those VMs offline. We're going to go and move them to our second node in the cluster. We're then going to load that in-state memory off the disk. So again, we're not cold booting the VM. Bring the VM online, reconnect our clients. So essentially, we're taking a snapshot of the current VM and moving that snapshot to our other node. Again, there is downtime. So let's take a look at live migration and what's different here. Well, with live migration, no downtime. That's the key thing here. But both of our nodes must be online and participating in the cluster to make this happen. So with the live migration, our administrator will go and initiate it. They'll say live migrate from first node to the second node, and we copy that in-state memory over. So with quick migration, we saved it to a disk and reloaded it. With live migration, we copy it over the network. Now, while this is happening, don't forget, our clients are still connected. They're still accessing that VM. Memory is still changing. And so we need to make sure that we capture those changes as well. So after we start that initial live migration and start copying the memory over, we keep track of any other changes that happen, anything else which gets modified, any dirty memory pages. And we then go and copy those over. We do this again and again. So gradually we're copying a lot of memory, then a little memory, even smaller, until essentially we have identical memory on my first node and on my second node. A change happens here, it happens here. So essentially we have clones of our virtual machines running on two different hosts. Now this is the part where we go and switch over our client. We redirect them from our first host to our second host. And so we do that by actually sending an ARP to the router and remapping our routing tables. So originally, a client was connected to our switch or our router. It said, go send them to node 1. We update the routing tables. The next time they make a request, they get sent to node 2. From their perspective, they don't really care where they're connected. They're just connecting to a bunch of in-state memory that's now moved from our first node over to our second node. So from the client's perspective, there's no downtime. They might just have a slight hang in the UI as they're being redirected from that first node to the second node, but no downtime. Now, with Windows Server 2012, we wanted to enhance this further. With our old version, you could do one live migration at a time. With this version, we can now do concurrent live migrations. By default, we configure all of our all of our hosts to do 2 simultaneous live migrations, but fully customizable. We have no limits. So if you wanted to do 100 at once, you're certainly welcome to do that. It really depends on your type of networking equipment and your throughput, as far as where's kind of my best practice, where's my optimization here. We have the ability to do live migration queuing. So let's say you can only do 5 migrations at a time. You have 20 that you're trying to evacuate. Well, you could select all 20, say live migrate. 5 will go, then another 5, then another 5, then another 5. Just to make things easier on you guys, right? Instead of having to keep going back to the UI, click it, perform another live migration, we will go and queue it for you. We also have the option to do a live migration to what we call the best available node. And with our best available node, what we will actually do is look at all of the different nodes in your cluster, figure out what has the most free memory resources, and we will automatically go and move that VM to that node that has the most free memory. Our goal here, we realize with virtualization, memory is the biggest constraint that most of our customers have, and so we wanted to make it easy when you think about, hey, I need to move my VM. Which of my 64 nodes should I go move it to? You don't have to think about that anymore. You just say, move it to the best available node. We will go and figure out which of your nodes has the most free memory, automatically move that VM over to that node. Now, Windows Server 2012, we also added new types of live migration. Now, with new types of live migration, our goal here is to really extend the boundaries of a cluster. In our old version, you had to do a live migration within a cluster, between different nodes of the cluster. With this, we could go beyond clusters, we could go between clusters, and a lot more. Now, the first type of new live migration is called storage live migration. In this case, we can move our VHD files from one storage array to a different storage array with no downtime for our VM. So let's say you need to do maintenance on a SAN. You got your VMs running. Go move that VHD to a different SAN, go do your maintenance, go move it back. No downtime to our virtual machine. We then have live migration over our network, or live migration over SMB. In this case, we have our VHD files on shared storage, or an SMB file share in this case. We have different clusters, different standalone hosts, and we can move our VM between different nodes, different clusters, different hosts with 0 downtime because we're redirecting all of our traffic through SMB. We then have shared nothing live migration. In this case, we're simultaneously moving our storage and our VM between different hosts with no downtime. And with this, we can actually have a single Hyper-V host with direct attached storage, live migrate to another single Hyper-V host with direct attached storage, no downtime. So this really allows you to extend your migration beyond the boundaries of clusters and have flexibility throughout your data center. The final related migration type is Hyper-V Replica. Now, Hyper-V Replica is a free in-box solution that allows us to do replication of virtual machines. And what we do here is every 5 minutes, we'll take a virtual machine and we'll go copy it to a different host, but not bring it online. Now, this is essentially a free in-box disaster recovery solution. Now, it's possible you could lose up to 5 minutes of data. If you do a copy every 5 minutes, it crashes after 4 minutes. There is a possibility for data loss, but this is a free in-box solution. And so what this means is, let's say I have 2 data centers. My first data center crashes. There's a power outage in the region. Well, what we can do is we can go to our second data center. We have our replicas that are available. They're at most 5 minutes behind. We just bring them back on our second data center. So we have in-box disaster recovery entirely for free. Now, Hyper-V Replica on a cluster is slightly different than Hyper-V Replica on a standalone host. When you use Hyper-V Replica on a cluster, we actually make the replication engine highly available. And so what this means is we will always ensure the replication happens for any VM on a cluster. So we do this by creating a new clustered role called the Hyper-V Replica Broker. When you actually go and add a new role to the cluster, you'll now see an option, Hyper-V Replica Broker. And this is essentially the replication engine that's online, and this engine will actually fail over between the different nodes. So if you have your replication engine on node 1 crashes, we'll actually move this replication engine over to another node, bring it online, so that we can ensure that we always have replication and have no downtime as part of our replication engine. Now, one thing that's kind of unique here is you cannot replicate within a single cluster, because the Hyper-V Replica Broker, there's only one per cluster. So what this means is if you're replicating using Hyper-V Replica between 2 different data centers and you're using a cluster, you'll actually go and configure cluster 1 on data center 1 with a replication broker, cluster 2 on data center 2 with its own replication broker. And again, so you could go standalone to standalone replica, standalone to cluster, cluster to standalone, or cluster to cluster. But again, you cannot replicate within a single cluster. But this is a new Hyper-V Replica, Windows Server 2012. Now let's quickly talk about clustering with System Center 2012. So a lot of people ask, why would I go use this? When's the time to go and upgrade to System Center 2012? Well, this is when you're starting to manage multiple clusters, many virtual machines, many hosts, so you can manage it from a single location. Try to optimize it, and have more automation and more tools built in. So System Center Virtual Machine Manager, it really allows us to manage, it's over 400 different hosts that we can go and manage using Virtual Machine Manager. We automatically detect configuration changes. We can automatically add new hosts to our clusters. We could deploy clusters through VMM. So let's say, for example, you get a new storage array. You go plug it into your data center, redundant power supplies, redundant internet connection. So long as Virtual Machine Manager can go and talk to that new storage array through its baseboard management controller, we could go and automatically add all of those hosts to our cluster, install the Hyper-V role, install the failover clustering role, and validate it. So SCVMM allows us to quickly build clusters, allows us to quickly scale up our clusters. VMM also supports other types of clusters as well, not from Microsoft. So we have full support for VMware and Citrix clusters. And then we use SQL clustering for all of the System Center databases. So System Center uses SQL as its backend database. You could go and cluster that database as well, using SQL Always On, SQL HA. We have what's called intelligent placement in Virtual Machine Manager. Now, I mentioned that we had this option to automatically place a virtual machine on the best available node. This kind of takes it a step further. This gives you the ability to go and place a VM on the best available node based on how you want to customize it. So you could say, for my host, what's my biggest constraint? Is it network I/O, disk I/O, memory, CPU? And maybe you're disk I/O constrained. You're running lots of SQL databases inside VMs. You could say, hey, I want to go and move my SQL VM to the node that has the most I/O. Fully customizable to reduce the amount of thinking you have to do. So when you say, hey, go move my VMs, it will automatically go and place those on the best available nodes. We also have a version of update management available in Virtual Machine Manager. It basically follows that same algorithm as cluster-aware updating. But the difference is this will also manage down-level clusters. So if you have a 2008 R2 cluster, update management will go and patch that. It also will go and patch anything else that Virtual Machine Manager manages. So if you have a library server that's clustered, it will go and patch that. So a lot of nice built-in options, a lot of flexibility with your cluster update management. Now, one thing to note is that it will not actually patch VHDs or virtual machines themselves. This just patches the host, the physical server. So you always have to think about, if you have a lot of VMs that are stored in a library, when you go and deploy those VMs, are those VMs patched? Are they up to date? Or after you deploy them, is there a security vulnerability? So we actually have a built-in, not a built-in tool, but we have a free tool that's available for download called the Virtual Machine Servicing Tool, VMST. And that will go and actually patch your VMs as well, which are stored in a library. So you specify the library, it will look at all the VMs, it will bring them online, it will apply the patches, it will take them offline, and put them back in your library for you. This way you can ensure that all of your VM images also stay compliant, they also stay patched. Dynamic optimization is a built-in load balancing mechanism with Virtual Machine Manager. What this will do is it will monitor all of your hosts. You could set certain thresholds, certain triggers, and if one of your VMs reaches a threshold, if one of your hosts is over capacity, it's overutilized, we'll automatically live migrate those VMs to a different host to help distribute all of the network, memory, resource utilization across all of the different hosts. Now, VMM itself can be made highly available in Windows Server 2012. We could actually go and run the VMM server itself on top of a failover cluster. So if the VMM management server crashes, it could go and restart on another node in the cluster. Now, beyond Virtual Machine Manager, that's our primary integration point with clustering. All of the other different system-centered components use clustering as well. System-centered App Controller is our self-service portal. With this, we could go and deploy our services to clusters. Configuration Manager gives us the ability to secure and patch all of our clusters and all of the roles that are running on the cluster. Data Protection Manager gives us the ability to go and back up and restore our clusters, our VMs, our files running on CSV disks, and it can even perform backup during a live migration. So you don't have to worry about when you're performing the backup, whether a live migration is happening. We can always ensure that we protect those VMs. System-centered Endpoint Protection patches our clusters and our roles against malware, other vulnerabilities. Operations Manager monitors the health of our different nodes, our clusters, making sure that they're performant, making sure they stay online. Orchestrator is our automation engine. This allows us to actually go and perform any type of task when we're using a cluster. So you want to go deploy a new VM automatically, add it to a cluster node, fully integrated with Orchestrator. System-centered Service Manager, our IT department's help desk tool. You can monitor the health, track issues that are reported on top of clusters. And finally, System-centered Advisor. This is actually a free download a lot of people don't know about. But System-centered Advisor, it's a free tool that runs in Windows Azure, and it will scan your entire data center and tell you if best practices are not being followed. And it will tell you missing hotfixes, missing patches, and it will go and look at Exchange clusters, SQL clusters, Hyper-V clusters, SharePoint, Link, all of the major Microsoft components. If you want to check that out, free download, systemcenteradvisor.com. And finally, performance and resource optimization. This is where you can get the most granularity within your cluster management. And so with this, you could go and use Operations Manager to set certain thresholds to look at different actions in the cluster. So let's say you want to have a report. If I have more than 20 VMs on a particular cluster node, I want to go and evacuate them. I want to move them to a different node. What we could do is Operations Manager will monitor the hosts. If it detects that a threshold has been reached or surpassed, it will go and tell Virtual Machine Manager, perform a live migration. Virtual Machine Manager will pick the best host based on your own intelligent placement algorithms, and it will live migrate that VM to the other host. No downtime for your VMs, and it will give you all this load balancing capabilities. Now, as I summarize, always remember, server downtime is inevitable. Clustering is still critically important for unplanned downtime, and you have a lot of flexible management options. You could use almost any hardware, and you could always enhance everything using System Center 2012. With that, I want to just mention a few more resources that we have. If you want to download these bits, try it out. The TechNet Eval Center offers free downloads. We also have a training program that we're running worldwide called IT Camps, which is run by other technical evangelists like myself. These are full-day, in-person training events for 20 to 50 people that come with a hands-on lab, fully immersive environment. So you'll spend the day learning about System Center, Windows, Azure, and get your own hands-on lab as part of that to actually play around and experiment with this. And we've run over 1,000 worldwide this year. So go to aka.ms/itcamps to learn more. And finally, the Microsoft Virtual Academy. This is our free online training portal. We have dedicated courses to clustering and high availability, Virtual Machine Manager, all these other System Center components. MicrosoftVirtualAcademy.com. Thank you.